Find the domain of each function. All right, so in this set of exercises, we want to basically pay attention to the 2 bullet points here at the end of this list. So the first one says that we do not want zeros in the denominator of fractions. So we have a fraction in the problem, we have to be concerned about the fraction becoming undefined when there's a 0 in the denominator, right? So we want to avoid any values for the independent variable that could end up causing us to have a 0 in the denominator. So we want to look out for that. So of course, if the problem doesn't have a fraction, that's not a concern, right? All right, the last bullet point talks about the idea of having no negative radicans under a radical that has an even index. So in other words, you're taking like the square root or the fourth root or the sixth root. We don't want to have a negative value underneath there, because if we have a negative value underneath there, we basically will get an imaginary number. So again, we want to avoid putting values into the function that would end up producing imaginary quantities. So we're basically going to, again, just be on the lookout here for fractions and radicals. So those are really things that are going to bother us. Later on in the course, we will cover something called logarithms, and at that point, we will be concerned about something that can go wrong there. If we plug in the wrong thing for the independent variable there, we could also have some issues come up. But for now, basically, if it doesn't have a fraction and it doesn't have a radical, we can assume the domain is all real numbers, right? So let's look at example A here. It doesn't have a square root, it doesn't have a fraction, so I would say that the domain then for this problem is essentially from negative infinity to positive infinity, or in other words, it is all real numbers, right? All real numbers. And it's that simple, that's all we have to do. So remember, the domain is basically what are you allowed to put into the function? What values for x are okay, for example, in problem A? Well, we can put any value in for x, right? Any number you put in there, you can certainly square it and then add 3 to it, and that's going to be fine. We won't run into any situation where we'll get a 0 in the denominator, and we won't run into any situation where we have a negative under an even root. So we're okay in A to put anything into the function we want. So the domain, the input in other words, can be any real number. All right, let's look at example B though. With example B, we do have a fraction, right? And because we have a fraction, we have to be concerned if that denominator should ever become 0, right? So we want to worry about that. So what we want to do is say, well, when would this be equal to 0, right? When is that equal to 0? That's our question, right? Okay, well, let's figure that out. Certainly we could factor that quadratic by saying x and x, right? It's a difference of 2 squares. So the root of 9 is 3. So we'll put 3 and 3, and then you remember it's plus and minus for the difference of 2 squares factoring. All right, so now we have a product, and that product is equal to 0. So we can apply the 0 factor property. So it will be x plus 3 is equal to 0, or x minus 3 is equal to 0. And that gives us the answer that x is equal to negative 3, and x is equal to 3. All right, so these two values end up giving us 0 in the denominator, because if you plug those values in, you'll see that what? For example, if I put negative 3 in, I would get negative 3 over negative 3 squared minus 9, which would end up giving you what? Negative 3 over 9 minus 9, which of course would be negative 3 over 0, and then we'd have an undefined fraction. So in other words, we want to avoid these two values. So basically we're going to say x cannot be negative 3 and x cannot be positive 3. All right, so with that in mind then, we're going to go ahead and say that the domain is all real numbers except for negative 3 and positive 3. But the way I want to write this is using interval notation. So I'm going to say the domain basically goes from negative infinity all the way up to negative 3. Now I don't want to include negative 3, so I'm going to round the bracket on negative 3. That way I'm saying go up to negative 3, like you can use, any number like negative 3.000001, that's fine, but you can't use negative 3 itself. All right, and then we're going to add to that, so a union symbol. We're going to pick back up at negative 3, not including it again, so the bracket is going to be rounded, right? And we're going to go up until we reach positive 3. Again, we don't want to include positive 3, so we're going to round the bracket there. So we can take any number close to 3, like 2.9999999 is fine, but 3 is not, so we round off at 3. And then we're going to union that to another set, basically starting at that 3 again, but not including it, and going all the way up to positive infinity. So it's sort of a complicated answer to write in interval notation, but that's basically it, right? What it does is goes from negative infinity to positive infinity, but leaves out 3 and negative 3. All right, let's take a look at C and D then. All right, so let's take a look at C. For C, we both have a fraction and a radical, so we got to be on the lookout of both issues that can cause a problem, right? So what are the acceptable values for x? In other words, what's the domain of this function? What can we put in safely in for x without running into the problems of a 0 in the denominator or a negative under the radical? Well, we have to try to answer that. So the first thing I'll do is say, well, what about the fraction part? If I have the square root of x minus 5 as my denominator, I do not want that to equal to 0. So when will this be equal to 0? Well, if we tried to solve this for x, we would square both sides, right? So we'd have x minus 5, quantity squared, and 0 squared. And if I did that, I would end up with just x minus 5, and that will be basically giving us 0 on the other side, right, on the right-hand side. And then if I add 5 to both sides, then I end up with x should not be equal to 5. What this is saying is, look, if you put 5 into here, you're going to get 5 minus 5, or 0, and the square root of 0 is 0, and that's not acceptable, because then we'd have an undefined fraction. Okay, so we know that x should not be equal to 5, so we have to leave that out of our domain. Now what about the other situation, which is we don't want what's underneath the square root to end up being negative. So we want to make sure that x minus 5 is greater than 0. Now, you can say x minus 5 greater than or equal to 0 normally, because under our square root, you're allowed to get 0. The square root of 0 is just 0. But we don't want to let it be 0 here because it's in the denominator of a fraction. So we need to remember that x minus 5 has to be strictly greater than 0. That way, the square root is something that we can obtain. It's not going to be imaginary, right? All right, and of course, if you solve this inequality by adding 5 to both sides, you're going to end up with simply x is greater than 5. So we have two kind of criteria here for our domain. X must be greater than 5, and of course x cannot be equal to 5. Well, if x is strictly greater than 5, then we don't have to worry about this, right? X being not equal to 5, that's not important. If x always has to be greater than 5, then it won't be equal to 5, right? So basically our answer for our domain then is simply the values from 5 to infinity, but we cannot include 5. And that's basically the end of the problem there. So we know that anything that's 5 or less will give us a problem. If it's 5, it gives us an undefined fraction. If it's less than 5, we end up with something negative under the radical, right? All right, let's do the last one then. The last one is D. Again, we're trying to figure out what is acceptable for the variable w, right? Well, this has both a fraction and a radical. So let's start with the denominator piece, right? We don't want w minus 3 to end up being 0. So that's easy enough to solve. We basically can say what? If we add 3 to both sides, then only when w equals to 3 will we have a 0 in the denominator. So we need to make sure that that can't happen, right? We don't want w being equal to 3. So that's part of our domain. That's a restriction on the domain, I should say. And let's look at the top part of the fraction, that square root. So we want to make sure that w plus 7 is greater than or equal to 0. Now we're putting the equal to in here because it's okay for a square root to have a 0 underneath it, right? That's all right, as long as it's not in the denominator, right? So in the examples that we had before, example C, that square root was in the denominator, so we didn't want to let the radicand give us something that was equal to 0. So we made sure that the radicand was strictly greater than 0. But here we can say greater than or equal to because the radical is in the numerator, right? All right, so because of that, let's go ahead and solve that. To subtract 7 from both sides, and it's very easy to see that w must be greater than or equal to negative 7. As long as that's true, we're going to be okay, right? So essentially, this is the rule for our domain, but we have to do what? Make sure that we don't include 3. So we have to sort of join these things together, right? So greater than negative 7 is all the numbers on the number line, right? From negative 7 to positive infinity. But we need to remember to exclude 3 along the way. We need to sort of get rid of the 3. So we're going to do something like this, right? So if we want to write that out in interval notation, we're going to say you can start from negative 7, but you can use a bracket there because we're allowed to include negative 7. That's okay. So we'll include negative 7. We'll use a bracket. We'll go up until we get to 3, but then we'll round for 3, saying we don't want to include 3. Then we'll pick up just after 3, right? So not starting right at 3, but just after 3, and go up to infinity. So we use the round bracket here on the 3 to make sure that we're not including it. All right, and that would be your domain for example D.